Hi everyone, today we are going to solve a question on electric field, basically the work done by the electric field and potential difference between 2 points. Let's read the question. When an electron goes from A to B along an electric field line, you can see the electric field lines are drawn in here, and it seems like the electron is moving in the opposite direction of the field lines, which makes sense because if you guys remember, we said the electric field applies a force to a negative charge in the opposite direction of the field lines. So we expect the electric field to apply a force to the electron in the opposite direction of the field line, such that the electron would go from point A to point B. And the question confirms that too. Okay, so to do that, the electric field does, so this amount of work, the work done by the electric field, it is equal to 3.94 times 10 to the minus 19 joules. So for the electric field to move the electron from point A to point B, it has to do 3.94 times 10 to the minus 19 joules. Now, they're asking for the potential differences between point B and A. They're asking for VB minus VA. Okay, so if you guys remember that, this is very, very important to remember that the work done, if you guys remember, we said the work done by us, which is a work done by an external force, it is equal to Q times delta V, which is the change in potential energy. Yeah, we said that Q times delta V, Q times the change in potential, which is equal to the change in potential energy, the change in U. Now, the work done by electric field, though, it is equal to the minus delta U, which is minus Q delta V. And this is always true, regardless of if Q is a positive charge or a negative charge. So the work done by the electric field equals minus Q delta V. Now, if the electric field is taking the electron from A to B, that delta V would be the final potential, which is VB, minus the initial potential, which is VA. Good. Now, if I sub in for the values I'm given, the work done by the electric field equals 3.94 times 10 to the minus 19 equals minus the charge of an electron is minus 1.6 times 10 to the minus 19 times VB minus VA. That's what you're looking for. That's your unknown. Basically divide both sides by 1.6 times 10 to the minus 19 after you cancel out the negative sign. Therefore, VB minus VA is, you're going to get 2.46 volt. Yeah. So therefore, you could calculate, I'm not going to calculate VC minus VA or VC minus VB because it's just basically the same process. But the point of this question was to remember that the work done by us, the work done by an external force equals Q delta V. The work done by the electric field, it is equal to minus Q delta V. And delta V is the final potential minus the initial potential.